Transistor. By the end of this lesson, you should be able to describe a transistor in terms of its terminals. Describe how a transistor can be used as a current amplifier. Describe how a transistor can be used as an automatic switch. At the turn of the 20th century, the triode in a vacuum tube was invented. The device amplifies signals on telephone lines as the signals are transferred across long distances from one switch box to another in the United States. Telephone conversations could be transferred across any distance as long as there were amplifiers along the way. Improvements were continuously made on the vacuum tubes to reduce the amount of power needed for the amplifications and the heat produced. The discovery of semiconductors resulted in the transistor becoming an important component in computers, cellular phones, and all other modern electronics. How do transistors work? A transistor is a small semiconductor device which has three terminals: base B, collector C, and emitter E. A transistor consists of two p-n junctions. When a p-type semiconductor, the base B, is placed between two thicker materials of the n-type, the collector C and emitter E, an NPN transistor is formed. When an n-type semiconductor, the base B, is placed between the two thicker materials of the p-type, the collector C and emitter E, a PNP transistor is formed. In an NPN transistor, the collector C and the base B must both have positive voltages with respect to the emitter E. There are two current paths through the transistor. One, the base emitter path, where the base current IB enters by B, and two, the collector emitter path, where the collector current IC enters at C. Both base current IB and collector current IC leave by E to form the emitter current IE. In a PNP transistor, the collector C and the base B must both have negative voltages with respect to the emitter E. As for the two current paths through the transistor, one, the base emitter path where the base current IB leaves by B, and two, the collector emitter path where the collector current IC leaves at C. Since the arrows on the symbols give the direction in which conventional current flows, 1. In the NPN type, the arrow points from B to E, and 2. In the PNP type, the arrow points from E to B. How does a transistor work? The flow of current in the transistor can be likened to a pipe system having 3 openings: B, base, C, collector, and E, emitter. A plunger is placed at the end of pipe B. What will happen if water is allowed to flow into C? Click on valve X to find out. If we provide a reservoir of water for C, the supply voltage, the water cannot flow because there is a big plunger blocking the outlet to E. The reservoir of water is called the supply voltage. What will happen if too much water is allowed to flow into C? Click again on valve X to find out. If we increase the amount of water sufficiently, the water will cause the pipe C to burst, just as if we increase the voltage to a real transistor. Thus, we have to keep the supply at a safe level. What will happen if water is allowed to flow into B? Click on valve Y to find out. When we pour water into B, water will flow along the base pipe and pushes the plunger upwards, allowing quite a lot of water to flow from C to E. Some of the water from B also joins in and flows to E. What will happen if more water is allowed to flow into B? Click again on valve Y to find out. When we pour even more water into B, the plunger will move up further, and more water will flow from C to E. So what have we learned? A very small amount of current flowing into B, base current, allows a large amount of current to flow from C, collector current, to E, emitter current, so we have an amplification effect. Thus we can control a big flow of current with a small flow of current. If we continually change the small amount of water flowing into B, then we cause corresponding changes in the large amount of water flowing from C to E. Similarly, in a real transistor, a small change in base current, IB, will result in a large change in the collector current, IC. The transistor therefore functions as a current amplifier. Current amplification of current gain is the ratio of change in collector current to the change in base current. Suppose an increase in base current, IB, of 1 milliampere would allow an increased collector current, IC, of 100 milliamperes to flow in the collector-emitter path. Then we can say that the transistor has a gain or amplification factor of 100. What will happen if even more water is allowed to flow into B? Click again on valve Y to find out. The amount of current that can flow from C to E is limited by the pipe diameter. So, no matter how much current we push into B, there will be a point which we cannot get any more increase in current flow from C to E. The transistor can be used to switch the current flow on and off. If we put sufficient current into B, the transistor will allow the maximum amount of current to flow from C to E. The transistor is switched fully on. If the current into B is reduced to the point where it can no longer lift the plunger, the transistor will be off. Only the small leakage current from B will be flowing. To turn it fully off, we must stop all current flowing into B. A circuit consisting of a transistor, two identical bulbs, L1 and L2, a resistor, a set of batteries, and a switch has been set up. What can you say about the bulbs when the switch is opened? When the switch is opened, neither L1 nor L2 lights up. What does this indicate about the base current IB and the collector current IC? When the switch is opened, base current IB equals 0. Thus, L1 does not light up. However, L2 also does not light up, even though the collector-emitter circuit is complete. This shows that when base current IB is 0, the collector current IC is also 0. What happens when switch S is switched on? Click on the switch to find out. When S is switched on, both L1 and L2 light up. This indicates that in a transistor, the base current IB switches on the collector current IC. A transistor is considered to be off when the collector current is 0 or very small. The transistor is considered to be on when the collector current is much larger. To switch a transistor on requires a base voltage, and therefore the base current, to exceed a certain minimum value, about plus 0.6 volts. What can you say about the brightness of the two bulbs? L1 is dim, but L2 lights up brighter. What does the brightness of the bulbs indicate about the base current IB and the collector current IC? Since L2 lights up brighter, this shows that the collector current IC is bigger than the base current IB. This indicates that the collector current IC has been amplified. What can you say about the function of a transistor in a circuit? In a circuit, the transistor 1 acts as a switch, that is, base current IB switches on the collector current IC, and 2. Base current IB controls the magnitude of the collector current IC. Can you suggest what the function of resistor R is? Resistor R is used to control or limit the base current. If the base current is too large, a very large collector current will be allowed to pass through the transistor, and this may cause overheating of the transistor. A circuit consisting of a silicon transistor, dry cells, a resistor R1, a variable resistor R2, and a bulb has been set up. Name the type of transistor used. The transistor used is the NPN transistor. Let V be the voltage across the dry cells, V1 be the voltage across R1, and V2 be the voltage across R2. How can you relate V, V1, and V2? Voltage across dry cells is equal to the voltage across R1 plus voltage across R2. Thus, V equals V1 plus V2. What can you say about the current that passes through resistors R1 and R2? Since resistors R1 and R2 are arranged in series, the current that passes through the two resistors is the same. Assuming the current passing through R1 and R2 to be I. What can you say about I, V1 and R1? V1 equals to I R1. What can you say about I, V2 and R2? V2 equals to I R2. How can you relate V, I, R1 and R2? V equals to I multiplied by the sum of R1 and R2. How can you relate V, V1, I, R1 and R2? Using V1 equals I R1 and V equals I multiplied by the sum of R1 and R2, the voltage V1, which is the voltage across R1, is given by V1 equals the ratio of R1 to the sum of R1 and R2 multiplied by V. How can you relate V, V2, I, R1 and R2? Using V2 equals I R2 and V equals I multiplied by the sum of R1 and R2, the voltage V2, which is the voltage across R2, is given by V2 equals the ratio of R2 to the sum of R1 and R2 multiplied by V. Since in a potential divider, V1 equals to the ratio of R1 to the sum of R1 and R2 multiplied by V, and V2 equals to the ratio of R2 to the sum of R1 and R2 multiplied by V, thus an increase in R1 will cause an increase in V1 and vice versa. This goes the same for R2 and V2. However, since V is the sum of V1 and V2, any increase in V1 will result in a decrease in V2 and vice versa, so as to maintain a total voltage of V. Vary the resistance of R2. Click on the rheostat to vary the resistance. What can you say about the readings of V1 and V2 as R2 increases? As the resistance of R2 increases, V2 increases, but V1 decreases. What is the sum of the voltages V1 and V2? The sum of the voltages V1 and V2 is the same as the voltage supply, which is 6 volts. What is the value of the voltage V2 when the bulb begins to light up? Click on the rheostat to vary the resistance. The bulb begins to light up when the voltage V2 is about 0.7 volts. V2 is also known as the base voltage, VB. When the base voltage, VB, exceeds a minimum value of 0.7 volts for silicon, 0.3 volts for germanium, the base current, IB, will flow from the base to the emitter. This will result in a large collector current flowing through the transistor. The transistor is said to be switched on. By varying the base voltage, the transistor can be switched on or off. A circuit consisting of a transistor, resistors, capacitors, a microphone, a speaker, and dry cells has been set up. Change the magnitude of the base current IB by varying the resistance of RB. Click on the slider to vary the resistance. What can you say about magnitude of the base current IB as the resistance is varied? What can you say about magnitude of the collector current IC as the resistance is varied? What can you say about the loudness of the sound heard through the speaker as the resistance is varied? As the resistance of RB decreases, 1. The base current increases. 2. the collector current shows yet a bigger increase. And 3. Thus the sound heard through the speaker is louder. A small increase in the base current results in a bigger increase in the collector current. Current is said to be amplified. This is a light-dependent resistor, LDR. A light-dependent resistor, LDR, is a resistor that is sensitive to light. In the dark, or when there is no light, the resistance of the LDR is high, and vice versa. A circuit consisting of a transistor, a light-dependent resistor, LDR, dry cells and 2 resistors, R1 and RB, has been set up. Drag the LDR and the resistor to any box, A or B. Click on the appropriate boxes and determine how the transistor circuit can automatically switch a bulb on or off during the day or night time. A heat-dependent resistor. Symbol when used in an electric circuit diagram. A thermistor is a resistor that is sensitive to heat. When there is no heat or low temperature, the resistance of the thermistor is high, and vice versa. A circuit consisting of a transistor, a heat-dependent resistor, HDR, dry cells, a diode, and 2 resistors, R1 and RB, has been set up. The diode is to protect the transistor. If the load is a motor, relay or solenoid or any other device with a coil, a large induced EMF and therefore a large induced current may damage the transistor when the transistor is switched off. Drag the thermistor and the resistor to any of the boxes A or B. Determine whether the alarm will go off or not when there is fire. Click on the appropriate boxes to lead you to the answer.